Given that we've now introduced the del operator, I'd like to define a couple of things that we'll be doing within this section. First one is going to be known as the divergence of a vector field. So let capital F be a three-dimensional vector field. Component functions will be p, q, and r. The divergence of capital F is, the notation that we'll use for this is div of capital F. And it's going to be defined as the del operator dotted with our vector field F. Now, for the record, what that looks like is the partial derivative with respect to x, the partial derivative with respect to y, and the partial derivative with respect to z, dotted with p, q, and r. So rather than thinking about this as a multiplication, you can think of this as applying the given partial derivative to the given vector or component function. So when performing this dot product, the partial with respect to x gets applied to p. So this will be the partial of p with respect to x plus partial with respect to y gets applied to q. So partial of q with respect to y plus partial with respect to z gets applied to r. That'll be the partial derivative of r with respect to z. Or if you prefer the subscript notations, it could also be written in the following fashion. Partial of p with respect to x, partial of q with respect to y, partial of r with respect to z, and add them all up. Now, starting with the same vector field, let f be equal to p, q, and r. The curl of f is defined as, first off, the notation that we use is simply curl of f. We don't abbreviate it to 3 letters like we do for the divergence because, well, it's only 4 letters, and one additional letter isn't too much of a trouble to actually write in here. This is going to be the del operator crossed with vector field f. Now that cross product we typically set up as a 3x3 determinant. So that'll be I, j, k, partial with respect to x, partial with respect to y, y, and partial with respect to z. And in the last line, p, q, and r. Now typically what I do with this is I recopy the first 2 columns, then go and give it a little slashy. Hope you don't mind. Anything that we wind up with on the bottom side, we'll account for with a plus sign, and anything on the top side, we'll account for with a minus sign. So for the I component down here, this will be the partial with respect to y of r. So partial of r with respect to y for the I component. For the j component, I see a partial with respect to z applied to p. So plus partial of p with respect to z for the j component. And for the k component, I see partial with respect to x of q. Partial of q with respect to x for the k component. Then we'll account for everything else with a negative sign up top. So for this k component, I see partial with respect to y of p. So partial of p with respect to y for the k component. For the I component, I see partial with respect to z of q. So that'll be plus partial of q with respect to z. That'll be for the I component. And for the j component, I see partial with respect to x of r. So partial of r with respect to x for the j component. Now let's gather all of our components together and put it into a vector. For the I component, I am seeing partial of r with respect to y, minus partial of q with respect to z. For the j component, I'm seeing partial of p with respect to z, partial of p with respect to z, minus j component up top, that'll be partial of r with respect to x. And for the k component, I'm seeing partial of q with respect to x, minus partial of p with respect to y. And there we have the vector definition of the curl of a vector field. We'll explain the significance in future videos.